Today we are going over simplifying radicals. There are two methods to simplifying radicals. There is the perfect square method, and then there is the pair method. So right now, we are going to go over the perfect square method. I am highlighting all my perfect squares in blue. These are going to be important because we know the answer to perfect squares. I know that the square root of 36 is a 6. I know the square root of a 4 is a 2. I know the answer for the square root of a perfect square. So let's look at some examples. So right here, we are looking for the square root of 200. What we are going to do, we are going to figure out what perfect square goes into 200. Right now, I'm using my calculator of decimals. And 200 divided by 100 gives me a 2. 100 is a perfect square. Check. 2 is a whole number. Check. So we can now write the square root of 200 is equal to 100 times 2. And we can pull this 100 out to the front because we know the square root of 100 equals 10. In the very front, rewrite a 10 times a square root 2. Next, for the pair method, for 200, we know it splits into 100 and 2 because 2 times 100 gives me 200, and 100 splits into a 10 and a 10. So we are going to write 10 times 10 times 2. We have a pair of 10s. So we are going to pull one 10 out to the front. And then we keep our root 2. Let's try another problem. Here we have 80. We're looking for what perfect square goes into 80. So right now, I am looking for perfect squares. And I have 80 divided by 16 gives me a whole number. 16 is a perfect square, check. And 5 is a whole number. So I can write here the square root of 80 is equal to the square root of 16 times 5. 16 is a perfect square, so we can pull the answer out to the front. Root 16 is equal to 4. So we have 4 times my root 5. Now let's do the pair method. So for 80, I could pull out a 16 and a 5, but I am going to show you a different way. I know that 40 times 2 is equal to 80, and I know that 4 times 10 is equal to 40, and that 2 times 5. And then this 4 can be split into a 2 and a 2. So I am going to go down all this roots. So factor tree, or at the very end. This 2 is at the very end. 40 splits into 2 numbers, and that's at the very end. This is at the very end, and those are the very end. So everything I highlighted, those are our factors. So we are going to write 2 times 2 times 2 times 2 times a 5. And because this is the pair method, we are circling our pairs. We have one pair of 2's and we have another pair of 2's. So I pull out 1, 2 from here. Pull out this another 2. And then I keep my root 5. And this simplifies. 2 times 2 is 4 root 5. As you can see, they are both the same answer. Now let's try the square root of 125. So 25 is a perfect square. And 5 times 25 is equal to 125. Let me show you in the calculator. 125 divided by 25 is equal to 5. So you can either math it out or you can just do guess and check and guess all of the perfect squares and check to see whether or not they give you a whole number as an answer. So we're going to pull this 25 out to the front because root 25 is equal to 5. Our answer becomes 5 times root 20 times root 5 because this 5 stays inside the square root. Next, let's do our factor tree. So let's do this the long way. So 5 times 25 is 125, and then we have a 5 times 5 gives me that 25. So inside of our square root, our factors is everything here at the end. It's going to be 5 times 5 times 5. This is a pair, so we're going to pull the pair out to the front, and then we keep our root 5. So they are both similar, both of them. You do look for perfect squares. One solely focuses on perfect squares, the other one focuses on all of the factors. So let's try 192. So I'm going to do 192 divided by 64 gives me a 3, and 64 is a perfect square. So all the factors of 192 is going to be a 2, 2, 4, 2, and 2. So let's write this in our square root. So we have 2 4s, and then we have 3 2s. So let's go ahead and circle our pairs. So our 4, since that's a pair, only one 4 comes out. One of these pairs come out. And then this root 2 stays the same. So now I'm left with 2 times 4 gives me 8, and our root 2 stays the same. So one thing I want to note is that here I have an image of primes. Everything highlighted in green, that is a prime number. So if we have something like a square root of 14, that cannot be simplified because 2 times 7 equals 14, and 2 and 7 are both primes. Another example is, what if we have had something like the square root of 8? This can be simplified because 4 times 2 equals 8, which means we have the square root of 4 times 2, or 4 comes out to the front because root 4, or 4 comes out to the front because root 4 is equal to 2, and we leave our square root of 2, and this 2 is a prime. So you know you are done when you A, reach a prime number, or B, whatever your answer is, it is a multiple of 2 primes. 15 is equal to 3 times 5, and 3 and 5 are primes.